right, how's everyone doing? Good. Very exciting. All right. My name is Nate Totten. I'm the CTO and co-founder of Zuplo, a modern API management, API gateway platform. And here today we are talking about the subtle art of API rate limiting. Let me figure that out. There we go. Really quick about me. So I've worked in a variety of roles: engineer, consultant, DevRel, customer success, product. Microsoft in the early days of Azure. It was so early we used to joke. I think it's okay to tell this now because Azure is big and successful. We used to call it like AWS, only a little bit worse and a little bit more expensive. But we didn't tell customers that at the time. Now it's quite successful, so I don't think it matters. They won't be offended. I was early at Auth0 working on docs and dev experience. Before Zuplo, I led the developer tools teams on the Salesforce platform. And now, as I mentioned, I work at Zuplo. So a lot of, I've always basically worked as a developer or in the developer experiences space. Super passionate about building tools and developer experiences, and that's what we're going to talk about today. So what are we going to talk about? Why do we need this? Why do I need to rate limit my API? No one's going to do anything bad. Doesn't matter. I bet most of your API, how many people have an API in here that is not rate limited? I won't tell anyone. Yeah, it's way more of you than that. We'll talk about what's the canonical right approach to responding to your customers for rate limiting. We'll talk about some choices, public, private, how much information do you disclose, and then some trade-offs in terms of how you do the rate limiting, optimizing experience versus latency. Talk about observability. If we have time, we'll do a little bit of a demo, and then I'll show you a big picture of my co-founder Josh's face on a slide and some links to content. So, why do I need rate limiting? Are people really going to attack me? Probably not. They might though. But it's somebody who's not meaning to attack you is why you really need rate limiting. I'll tell you a quick story here. So, about a month into my job at Microsoft, I'm very proud of this job. You know, it was my first big boy job at a real name brand company that people knew about. I get a call from my old manager at the small place I came from. I was a social media marketing site, like way back in the day, early social media. Back in the day where if you logged into a thing, we just took all of your information, like all of it. But we gave you like a coupon for something, so everyone was fine with that. But it actually took a while to get all this information from Facebook. We called a lot of our APIs. We downloaded everything into Azure storage. And we had this API that was failing, so we weren't getting all your data, and we didn't like that. So the last week I was there, I went to fix this problem, and I just put a little retry policy on the thing, no big deal, and then I left. And about a month later into my new job, I get a call from my old manager, and he says, our Azure bill was $35,000 this month, which is a lot more than it normally is. And, what's this have to do with me? Said, so you forgot you switched around a greater than or equal sign, as happens, right? This was the mistake. So fortunately, Microsoft was nice enough to refund that. But effectively, we were actually hammering our own APIs, like an insane amount that were then hitting Facebook. I don't think Facebook actually cared, and Azure certainly didn't care. They were just charging us for it. But they were nice enough to refund it. But that is one of the reasons why you need rate limiting, because developers tend to flip around greater than or equal signs. So obviously, protecting your resources is important too. Things get expensive, as I just demonstrated. You also want to ensure a good experience for all of your customers, right? You don't want one of your customers to just kill the experience for everybody else. You want to discourage abuse. And also, probably just as importantly, you want to enforce your business model. So a lot of people charge for APIs. Rate limits and quotas are often part of what your customers are paying for. Your free customers, your smaller customers maybe get 1,000 requests a second or an hour or whatever, and your granddaddy customers paying you 50 grand a month can basically do whatever they want, right? And so rate limiting is about enforcing your business model. So what does a rate limiting response look like? There's a couple things here. First, the status code, 429, that's the right status. If you're not returning that, you're doing it wrong. It's one of the very specific HTTP statuses. I kind of wish there were more, or maybe this one wasn't as specific. But this is basically the right status for rate limiting. Header. There's a, I believe, I can't actually recall, I believe this is a standard header now. It used to be like X retry after or whatever. There's a few headers that you often apply to rate limited responses. The retry after header in particular will tell you how many seconds to wait before your rate limiting, your quota sort of is reset. There's a few other headers that you can use, or I don't know if they're standard optional headers. And then you should return a response body. This is the format we sort of prefer. We're a little opinionated in our gateway. This is the default format. It's not a standard, it's a proposed standard. It's called problem details. But this is basically, pick a standard way to return error messages. Probably the guy before me talking about API design talked a little bit about this. But, provide users information to make a decision. Detail here, you made too many requests, try again later. Pretty obvious what to do. So the header is something that you'll want to decide, do you want to expose? Or more broadly, the information about should the user retry, when should they retry, et cetera. So if your API is like free and you've got a ton of users, like one of the downsides of providing that information from the user is that it's very easy for a malicious actor to just stay right underneath the limit, right? They can, if you, say retry after this many times, or you say you have this many requests left, they can just stay right under it. However, building a great API experience, I would definitely encourage you to give the user as much information as possible. Particularly your paying customers, people that you have a relationship with. It's very easy to call them and tell them to stop abusing your API if they are using it for that purposes. The reality is, though, I don't really put too much. I really don't put too much value in hiding that, because ultimately, if someone is going to do malicious stuff, it's pretty easy to figure this stuff out, right? They just hammer your API, then they wait a period of time, and then they try and see, So I think generally speaking, I would recommend putting these headers in, returning as much information to your end users, your developers, or the code they write that's consuming those APIs is very helpful. All right, so how to apply rate limiting. The most obvious thing and kind of the default is IP-based, right? I think we all probably know why this often isn't a great choice. Maybe your customers are other services and they all happen to be in the same data center and maybe they share the same pool of IP addresses. Well, rate limiting one bad actor is going to affect the other bad actors. Maybe they're in a WeWork. I think these still are around. But maybe all of those users in a shared office or whatnot are all coming from one outbound IP address. Again, if you're rate limiting only by IP address, you're going to end up potentially punishing non-malicious actors for something that somebody else does. The other one, too, that's I think quite common now is if you're unlucky like me, I actually have a shared NAT on my ISP for IP4s. So like I share an IP address with a whole bunch of my neighbors, which it's terrible. It breaks a whole bunch of things, but there's not enough IP4 addresses. So if one of my neighbors is doing something on a site, I get that little like Cloudflare, are you human kind of thing a lot because of things like that. So that's kind of the reasons why IP-based rate limiting. I wouldn't use it unless it's for like a very, very high level thing, or you have a very specific use case. So more appropriately, rate limit by user or by something like an app. So GitHub, for example, if you're creating an integration with GitHub, you create a GitHub app, and GitHub actually applies rate limiting to that app because there's a number of API calls that are basically made acting as that app. It also applies rate limiting based on the users of that app. So like if I, as an app owner, get a credential for a user to act on their behalf, I get like a certain number of requests per app, per user in a period of time window, things like that. So that's really the better way to rate limit. That's going to ensure that there's not going to be side effects to non-malicious actors. How do you build a rate limiting system? I wouldn't recommend doing this unless it happens to be what your product is, one of the features of your product. If you have a simple setup, though, it is relatively easy, right? If you're running one server, go download a library. There's an NPM module, Python, whatever, and you can have an in-memory rate limiter. This will work fine. I mean, I'd recommend having it just so that your server doesn't crash if someone does something silly. But most people don't have one server anymore, right? So The more common setup is you're going to be in a bunch of pods, a bunch of servers in the same data center. This is, again, relatively straightforward. Typically, you would use Redis or something similar as your backing store to keep track of effectively counters. That's basically what a rate limiter is, right? Counting this key versus this number. You can spin up a Redis service in AWS or Azure or whatnot, and then probably use that same library. Relatively straightforward. Doing globally distributed rate limiting, this is where I would probably not recommend doing it yourself. There are ways to do it. You can use you could use enterprise Redis, for example, that does actually do geo active replication. I'll give you a warning though. It probably will cost more to run that than your API, so that's probably not the path you want to go down. You can also build it yourself, which is sort of what we do. We use Redis quite a bit, but we have replication. This obviously becomes quite hard, and there's a lot of decisions once you start to move into the multi-geographical distribution of rate limiting. So the big thing here becomes latency. So there's always a trade-off here between latency and experience. Any API, the goal really should be to have the lowest latency possible, right? Don't make your customers, your users, whatever, the machines calling your API wait. So the red here shows the hypothetical time it takes to actually enforce a rate limit. This would mean essentially checking against your counter service, Redis or whatnot, and seeing, is this bucket, is this user, is this IP address, is this whatever, over the threshold that we've established. That does take some period of time. Now, again, if you're in a single server or a single data center, that might not take too long. It doesn't take that long to call a Redis instance hosted in the same VPC in AWS or whatever. But again, if you're in a geo-distributed system, that might add 20, 30 milliseconds, right, depending on where those services are, depending on how many of them you have, depending on replication, things like that. So you're going to potentially incur latency on every request. But it will allow you to be sort of perfectly accurate. A better approach, in my opinion, is to do asynchronous rate limiting. So this means you're going to effectively do the check if the user, the bucket, whatever, is over their limit after or in parallel to the incoming request. This is how we manage. This is kind of our default model where we use caching to sort of keep track of the current count for a particular bucket. If the current bucket is over the limit, you can cache a lot of results. These are just keys and a number, right? You can cache tons of those in memory or in some local Redis or whatever very easily. They don't take up a lot of space. So if you're over the limit, this is easy, right? You have an in-memory cache on all your services. If the request comes in and they're over the limit, great. You say, hey, you're over the limit, easy, no big deal. If they're under the limit, this is where now you're going to, on another thread, another process, whatever, you're going to do the check, which is effectively incrementing the counter and seeing if you're over in the background, parallel to the request. This means the request is going to go through. So the trade-off here is you're going to have potentially some requests go over the quota, right? In a large system with lots of instances, with lots of requests coming in multiple locations, some amount of requests are going to potentially get over the quota. But I think the trade-off, is almost certainly better, right? Rather than making every single request pay that latency penalty just because they might eventually be over the quota, let a couple hundred or 10 requests in a million over the quota, in exchange for increased performance, decreased latency. The only exception here would be, of course, if the API calls are very expensive, right? Like if you're doing something, I can't think of an example, something with Bitcoin, probably, right? I don't know. That's not my area of expertise. But if you're doing something that's expensive, that's when you might say, like, look, it's fine that these people pay the latency penalty, these requests pay the latency penalty because it costs me too much money for even 10 to go over. Perfect. Great. So the last bit here is observability. So one of the things you'll find if you add rate limiting to your API, if it gets enough traffic, is when you add rate limiting to your API, you will get a lot of support requests. naturally people are, especially if you just start adding it and you didn't add it before, everyone's gonna be like, oh, well, what's going on? My infinite loop is now not working. They'll be unhappy about that. So both you as the developer and your customers ideally will have some visibility into what's happening in the system. Requests per second. What buckets are being are most active? How many users, how many buckets are over the limit? Breaking down by IP, by user, et cetera, right? You want some sort of telemetry. Ideally, you have this, again, both for yourself and both for your end customers. If your the best systems, the customer themselves can go and say, hey, I see this API key, or this user or this IP address or whatever is hitting the rate limit, and here's why, right? That's going to help you, as the API owner, have less support tickets and have more happy customers. Having that observability for you is going to help make sure that your rate limits make sense, right? If most of your customers are hitting the rate limits, well, maybe it's time to buy more servers or or increase the rate limit, let your system scale up more, right? If nobody's hitting the limit, up to you, right? Awesome. So I have talked quickly, so we have a few more minutes. So I want to, I want to give a quick demo, try to get us back on time here, and then, just talk a little bit about how we could implement a very quick rate limiting service using Zuplo. So just really quickly, I wanted to kind of give a demo of, in my opinion, what a good rate limiting system looks like, and some of the best practices kind of thing. So I've got this API here that I've made in Zuplo. This is our UI Zuplo API gateway, just with a to-do list sample here. So, adding rate limiting by, this is interactive too if you want to type a long URL. It doesn't have to be, but it's more fun if you, normally I copy and paste and send it to people, but I don't have your phone numbers. So I'm going to add a rate limiting policy here to Zuplo, and I'm going to set rate limit by IP address. I'm going to just set to 5 requests per minute to make it very obvious, right? Click OK and hit save. And so we can obviously see the problem. If someone does want to, it's a bit of a long URL, but if someone's, it's way too long, it's way too small. Can anyone see that? No, probably not. All right, I'll just do it myself then. So obviously, the problem, if we were all in the same, we're all in the same room, we're all in the same IP address. If I put a rate limiting policy per IP, then as we'll see here, let me just hit this a couple times, 5 to be exact. Did I hit save? I'm not calling. Hang on. Sorry, I wasn't calling the right API endpoint. Let's call this there. There we go. Too many requests. So I put an API rate limit on here for 5 requests from the same IP address in a 1-minute time period. I've obviously hit that very quickly. So 429 response. You will see here there's some headers. Sorry, the screen's a little small. Oops, now I can't scroll. There we go. So we have the retry after header, retry in 56 seconds to help me as the developer know that, hey, what's going on? Oh, I have to retry later. And then we have an error message in the body that tells me I've made too many requests. We could further add to this that explains something if, say, I was on a free plan or I was a paid customer or something. You could further explain the detail to say like, hey, you're on a free plan. Use your API key to get more requests. Okay, I'm going to keep going just for a quick second here since I started 3 minutes late, but I won't go too long. So a better solution then, as we kind of discussed, is to add API keys authenticate by user. So if I add our API key authentication policy here, and go create an API key for I have an API key. I'll grab an API key for this now, and then change my rate limiting to be, instead of by IP, by user. Now, again, in theory, if you all had this endpoint, authorization. So I'll put my API key in there, and now I can make a request. So now, the demo is not super great because we don't have anyone else in the room who can do this, but imagine in your head if you all also had API keys, then of course you could continue to make these requests and have your own rate limit not subject to my abuse or not of the particular API. And with that, thank you all for coming. Any questions or anything?
All right.